Welcome to topic 3, knowledge discovery. And in this short presentation, I'll canvass some of the main aspects of knowledge discovery. There's a lot more on the Interact site that goes into significant detail, and I encourage you to use this presentation as a bit of a signposting operation, and then obviously use the Interact notes to provide a bit of a deeper meaning and to get even a more rich experience. Obviously you'd go and look at the have a look at the readings and clips that I've put there on the site as well. So to begin with, we'll look at what discovery knowledge is. So let's have a look here. There are some 3 themes that we'll canvass, and they're very broad themes, but the first one here is understanding knowledge discovering and data mining. So what we'll learn is where or what knowledge discovery is and how it fits in with data mining. We'll then look at trying to make sense of data. What are the structures and what are some of the ways that we need to approach data analysis, and which then leads to knowledge discovery. And finally, we'll talk a little bit about predictive and risk assessment based on knowledge discovery, and we'll highlight some of the ways that predictive analysis can work, and some of the ways that it sometimes causes some issues as well. So they're the 3 themes that we'll cover in this presentation. So if we look at the first theme, let's have a look here at knowledge discovery. Knowledge discovery is really about the process of when we've found meaning, we've got data and we've found some patterns in that data, and the data has provided us with some knowledge, and that's really what knowledge discovery is. So in some ways, knowledge discovery is about locating that data, and sometimes it's also referred to as data mining. But I've sort of, in my mind, made a bit of a small distinction here, in that I think that data mining is probably the verb that we'd use to reach knowledge discovery, which would be the goal. So knowledge discovery is about finding patterns in the data, but to do that, obviously, you've got to mine the data to see the patterns, to find the patterns there. Now, the process towards knowledge discovery has been recognised in some ways as a 5-stage process. And on the Interact site, I've provided another copy of this graph here, which I've taken from one of our texts, which has a link to it on the Interact site. And here they've broken down the process toward knowledge discovery, and I thought it worth us just having a bit of a look and a little bit of a talk through that. As you'll see there in the beginning, we're provided with data, and within that data we obviously make our selection, and our selection of the data that we pull out from a larger source of data is obviously going to be based on the intelligence requirements or requirements of your directive. And so, taking out the targeting data, we then need to look at ways of processing it, which is the next stage. So processing it is really about removing any errors from the data that we found, any major anomalies, also looking at where there might be missing fields and so forth. And so where the data becomes pre-processed. So we're organising it into a way that we can, making sure that it's as clean as possible. Now, in terms of the next stage is about transformation. Now, the transformation is putting that data into a format that's going to meet our research requirements. So it's about how do we lay out that data and view that data so we can visually understand it and see it. Followed by the next stage, which is data mining. Now, data mining is when you're actually looking at where the patterns are. So sometimes the patterns are based on things like frequency. Sometimes they're based on volume, so how much of something is happening, how often is something happening, and you're looking for any patterns in regards to that. So you're looking at seeing what the data is actually telling us. And that's what the mining section is. But it's the evaluation process, that last process, the evaluation and the interpretation process that leads us towards knowledge. It's the analysis of it. And so in many respects, when we look at the process of moving to knowledge, we can see through tables like this that there is a very distinct and organised process to doing this. Now, I suppose when we look at data and knowledge towards data, it doesn't hurt to go back one step and just have a look here at some of the issues around data processing. Now, an organisation will probably put a lot of its resources into collecting and processing data, and some may say put more resources into that than they would even into the analysing of that data. Mostly it's because the better the data has been processed, the easier and more effective the analysis is going to be. When you're working with data from other people, it can sometimes be difficult because you don't have that context. And it's very often that other people are doing the processing and you'd be doing the analysis. And so it's important to understand the context in which that data has been processed. So you have a good understanding of the definitions that they've used, the rules that they've used, and that way, when you approach to analyse it, you have that necessary background, which is incredibly important. I guess another important aspect is to examine the difference between working out the measurement used in the data process. So, in many ways, in trying to work out frequencies of things and so forth, all those things are pretty much equally weighed. In other cases, you may find that there might be different values placed on different aspects of data. And you may even find that there may be an issue of ratio that needs to be developed too, to what, to the extent is something happening to something else. And so there's some of the more complex ways, I guess, that you want to be able to compare data, and that's what they're on about. So the easiest way is that if the data is of equal value, other ways are if they're of different value, then you've got to rank that particular value, and also sometimes form some sort of ratio as well. So I guess the importance of this part here is to be able to understand some of the nuances around choosing the right sort of measurement for data as well. So in terms of building and analysing data sets, some other fundamental decisions have to be made as well. Things like how is the data going to be, the information going to be used, how can the data be understood, how can it be manipulated, how can we examine it. And so this begins, I guess, with the data collection, obviously, and also the storage of it as well. But it's also important that there is a degree of coding to it. You need to be able to code data, you need to be able to structure it, and you need to be able to provide integrity checks to that data. We spoke a little bit before about integrity checks in the last topic, particularly with Fusion, and the difficulties that can emerge if you don't have something to validate it against. So in doing your integrity, you need to make sure that there is something you can check it against. Now, we know that data collection involves acquiring data, and we know that we've gotten it through a variety of means. We also know that large quantities of data can be extracted from a range of different sources. We know about using partner agencies and external entities and so forth, and we've talked about the fusion of those previously as well. We won't go down that road again, but I think we're aware of the various different ways that data can be collected. It might be worth now just having a look at how we might make sense of the data. Now, to make sense of data, we really need some way and some structures to view that. And often the best ways to view data is really using analytical tools, obviously. And analytical tools and methods such as the quantitative and the qualitative methods are some fundamental but very reliable forms of approaching analysis. Now, for the most part, as we know, the quantitative tends to deal with numbers, and qualitative tends to deal a little more with text and so forth. And so you need to be able to work out what type of method is most appropriate. And it really depends on what the intelligence request is. If it's a statistical approach, then obviously your quantitative analysis or method is going to be probably preferable. If you're looking at text, if you're looking at analysing text, whether they be emails, messages, well, qualitative method is also probably going to be a better approach as well. I put on the Interact site a little YouTube clip that compares and shows the differences between quantitative and qualitative methods. So by looking at that, you should probably get a pretty good idea about some of the ways to approach it. Now, I guess the going back to the ideas of making sense of data really also involves the way of being able to visualize it. The being able to, whether it be through graphic representation, through numbers, whatever, the visualization of that data will assist you to make sense of it. So it's important that the data is displayed in a way that makes sense and that has that is readily understood by yourself as the analyst. So it's really about, I guess, making sure that the data also contains variables as well, so you can compare and measure. And also you could be looking at various other, I guess, types of data approaches. So it could be a time series approach, any number. But it's about choosing the representation method that works best for you. Now, I think, as I say, it's really about making sure the representation is right, which then leads us, I guess, to some ways that analysis, predictive analysis, is used with respect to discovering knowledge. Now, the term predictive analytics is used to describe, I guess, a lot of data analysis methods that assist us to interpret data. Now, predictive analytics, as I've said, are often associated with big data and are used, I guess, to try and get meaning from large bits of data. I suppose some ways of thinking about what predictive analytics does and how it works would be the way that spam mail is filtered, but also the way that marketing and online services tend to work as well. These particular predictive analytics tend to make assumptions about data and matches certain profiles or patterns. And that's how the predictive analytics works. Now, there is a classic example of this where the retailer Target had undertaken a form of predictive analytics. In the US, a teenager had received some marketing information for baby products. She'd gotten that in the mail. Now, that had come about because Target had matched patterns in her shopping behaviour that indicated that she had a high likelihood of becoming pregnant. So the incidence, I guess, of this sort of predictive analysis really creates a lot of debate. And, we can see, in some ways we can see the predictive analysis often. How many times have you may have been on Facebook and a particular ad's popped up or so forth. In ways, that's also a form of predictive analytics, in that they'll know, based on the conversations you're having or the likes of particular pages, where you'll be able to use those likes to provide them with the particular types of advertising. So predictive analytics is a very interesting field, but it's problematic, particularly in terms of privacy and so forth, as in the case with Target there. Now, predictive analytics, I guess, can also be used to classify new data on trends in old data, or it can also, I guess, use forms of cluster data and provide a whole, I guess, range of different analytical opportunities. Now, as I said, as predictive analytics offer a rich and a variety set of tool sets to use, it does have some problems. Predictive analysis is based on humans, based on input, and so interpreting what people are going to do are quite high. So in the case of the teenager with Target, the interpretation could have been completely wrong. And so when you're looking at prediction, you need to be mindful that in reality it can sometimes be a lot different to what the predictive analytics would say. So don't underestimate, I guess, the role of human decision making when it comes to events as well. Often that can't be done through predictive analytics. So I think I provided you with a very broad overview of knowledge discovery, and as I say, it's one of those areas where you really need to sort of methodically work your way through the readings, methodically work your way through the ideas, and so forth. And to help you along that way, I've provided these readings here that will take us a little bit deeper beyond this presentation by all means, and by the notes on the Interact site, and will provide us with that little bit more context there as well. So go through those readings as I get to take your time through them, think about them, discuss your ideas on the forum posts or so forth, and you'll find the more you engage with these, the better your understanding will be. And as always, I've included some study questions, and these study questions are based on the readings and the interactive material as well. Of course, they're not, as always, they're not accessible, but hopefully they might help direct your learning and your understanding a little bit further. So that sums up, I guess, topic 3 for us. By all means, if you have any further questions, don't hesitate to contact me, and I look forward to providing another presentation when we move into topic 4. And in that next part, in the topic 4 section and beyond, we'll start to use these and revisit some of these analytical tools in a bit more detail and in a bit more of a practical sense. And I'm a bit of a firm believer that it's through doing that we're going to learn, and so hopefully we'll gain a lot more understanding about knowledge discovery as we start to actually embark on it. So by all means, please send me any questions or any issues that you might be having. Thank you.